Okay, we said we were going to use two different methods for finding unusual results, depending on the problem, what we're asked to do. One was to use the range rule of thumb, and the other was to use probabilities. So, in this video, we want to look at using the range rule of thumb to identify these unusual values. So here's an example. We want to let our random variable x represent the number of, see we're in still a discrete probability distribution, the number of light bulbs that will burn out in the next year if there are 8 light bulbs in the room. So it's already been computed that the mean number of bulbs that will burn out is 1.8 bulbs, and the standard deviation is 1.2. We already have that information. In another problem, perhaps later, you might have to calculate that to move on to this point. But say we already know that. Then we want to find this range of unusual values. Okay? Well, we saw before, we were told that when we're talking about the range, there's a calculation we could do that involves the mean and the standard deviation, and we've been given those. So we found that the minimum usual value was equal to the mean minus 2 standard deviations. So in this case, we've been given that the mean is 1.8 and the standard deviation is 1.2. So that would be 1.8 minus 2.4, and we actually get this negative 0.6. Now recall that we often get values for mean that perhaps are not values we can actually get because we're using discrete probability distribution, but we have a mean here of 1.8. Well, in this case, for minimum usual value, we might get a value that doesn't make any sense. A number of light bulbs, we can't have a negative 0.6. But what's that telling us? Basically, that just says that even 0 isn't unusual, right? So we're not alarmed by this result. This is just our result. We just take it as it is. Okay, our maximum usual value is equal to the mean plus 2 standard deviations, or 1.8 plus 2 times 1.2, or 1.8 plus 2.4. And here we get 4.2. Again, this is light bulbs. We can't get 4.2 light bulbs, but this gives us a point, cutoff point, so that we can use to determine maximum usual values and minimum usual values. Okay, so let's interpret this. So we conclude that for 8 light bulbs, the number of bulbs that burn out in the next year, so we conclude that for 8 light bulbs, the number of bulbs that burn out in the next year should usually fall between negative 0.6 and 4.2. That's our usual range. We were asked to find the range of usual values. Here it is. Now, in reality, what is that saying to us? Between 0 and 4, right? Because we can't have 4.2 and we can't have negative 0.6. So in practical application, we'd say that the minimum is 0 and the actual maximum is 4. But This is the computed minimum and maximum. Okay, well, part B, let's see what we're asked to do here. Well, this is how we can use this information. Would it be unusual for 4 bulbs to burn out in the next year? Well, let's look. Is 4 in the unusual part of the range of this data set, or is it in the usual part? It would be in the usual part, right? Because 4 falls between negative 0.6 and 4.2. So would it be unusual? No. Since 4 is between negative 0.6 and 4.2. We said that's our usual range. 4 is in the usual range. Okay, well, how about another question then to consider? Would it be unusual for 5 bulbs to burn out in the next year? What's the answer there? Yes. Since 5 is above the maximum usual value of 4.2. Okay, so that's how we can use this information to answer questions about this situation. Okay, now, as I mentioned before, because our minimum was this negative and that's not possible, there is 0 would not be unusual, right? So in this case, there's not anything unusual on the low end, but anything above, in actuality, anything above 4 is going to be unusual.